Hello students, welcome to Eshwari Thaniksha channel. Students, today we are going to start organic chemistry series. So if you are finding organic chemistry difficult, go through this. 100% sure you are going to get full marks in organic chemistry. Your confidence level will be boosted. So what you are going to study in this video is, students, you know that NCERT should be studied line by line. Only you can score very good marks in NEET examination. So see here, instead of learning each and every line, since it is time consuming, all the important concepts I have written in the stick notes here. So you can see I have written stick notes, the important points I have written here. So instead of going through each and every line, so go through this stick notes. It will save your time. So minimum 6 times you have to revise each chapter. So how much time it will take, how much time it will consume. So if you are using this method, 5 to 10 minutes is enough to revise one chapter. And also you can see here I have attached previous year questions, how the question can be asked, and here you can make comparison and you can study. So here you can see I have attached all the stick notes. And also what we are going to learn is, see here, tricks I have attached. So use these tricks so that you can remember everything very well. And also we are going to learn examples. So each and every example we are going to learn in this video. And also in text question, if it is there, we are going to solve in text question as well. So it will be 100% useful to you. So let us start this chapter, that is haloalkanes and haloarenes. So first page, what is very important is only learn this much. What are haloalkanes? So if halogen, X is called as halogen. If halogen is attached to sp3 carbon of alkyl group, then it is called as haloalkane. If halogen is attached to sp2 carbon of aryl group, that is benzene, it is called as haloarenes. And then chloramphenicol, it is an antibiotic used for treatment of typhoid fever. And then thyroxine, that is iodine containing hormone, it is used for treatment of goiter. And then chloroquine, it is used in the treatment of malaria. And then halothane, it is used as anesthetic. So learn only this much from the first page. We will go for the second page. So in second page, what is more important? So what is more important in the second page is, you should know what is allylic halide. Allylic halide meaning is halogen will be attached to sp3 carbon, and that sp3 carbon will be attached to carbon-carbon double bond. Benzylic meaning is halogen should be attached to sp3 carbon, and then sp3 carbon will be attached to benzene ring. So here you can see NEET 2023, this question is asked. So before going through, we will see what is vinyl and aryl as well. So here you see vinylic halide. So halogen is attached to sp2 carbon, that is double bonded carbon atom. And here in aryl halide, halogen will be attached to sp2 carbon of the benzene ring. So here you can make comparisons here. So if it is sp2 carbon, these two options you have to select. If halogen is attached to sp3 carbon, then from this you have to choose one. So let us solve NEET 2023 question. The given compound, so this is the compound which is given, is an example of 4 options are given: vinyl, benzyl, aryl, allylic. So we will see halogen is attached to which type of carbon atom. So halogen is attached to sp3 carbon. So how you know that this is sp3 carbon? If single bond is present everywhere, see here this carbon has single bond, single bond, single bond and single bond. So if single bond is present, then this is sp3 carbon. So if it is sp3 carbon, what is the two option for us? sp3 carbon means it will be allylic or benzylic. So we will see. And this carbon is attached to carbon-carbon double bond, which is outside the benzene ring. Therefore, it is allylic halide. So this is how you have to answer. So this much you should know from this page. So here it is given about vinylic and arylic halide. And here next they have given about two types of halide, which is geminal halide and vicinal halide. So what is that? See, geminal dihalide meaning is same type of halogen should be connected to one carbon. So this is called as geminal dihalide. Vicinal dihalide is same type of halogen should be connected to different carbon atoms. So see here what is given. The dihalo compounds having both halogen atom are further classified as geminal dihalide when both the halogen atoms are present on the same carbon atom. Then it is geminal dihalide. So vicinal dihalide is when halogen atoms are present on adjacent carbon atom. So adjacent carbon atom meaning is next to next carbon atom it should be present. Then it is called as vicinal dihalide. So this much you have to learn from this page. Next is IUPAC nomenclature. So students, tricks on IUPAC nomenclature I have already made. Go through those videos, 100% it will be useful to you. Next we will go for nature of CX bond, that is carbon halogen bond. So here halogen, you know that they are highly electronegative when compared to that of carbon. Therefore, they will pull this bonded electron towards themselves. As a result, they are going to get partial negative sign and carbon atom is going to get partial positive sign. So this much you learn from here. Next, you should learn this table, that is about bond length, bond enthalpy, dipole moment. For this, I have written the trick here. So what is the trick you have to learn is change in electronegativity. If it is increasing, dipole moment also increases. So let us see how. See in the table, this is carbon fluorine bond. So carbon and then fluorine bond. So here electronegativity of carbon is 2.0 and then fluorine atom is 4.0 electronegativity. What is the difference here? The difference is 2. We will take last one and compare. So carbon is 2.0 and iodine is 2.6. So what is the difference? Difference is 0.6. Where the difference is more, the difference will be more here. Electronegativity difference is high here. So if the electronegativity difference is high, then the dipole moment also should be high. So therefore dipole moment should increase in this order. For iodine it is less, for fluorine it is more. So dipole moment should increase in this order. Check the value: 1.84, 1.86, 1.83, 1.63. So here chlorine is more when compared to fluorine. So that is the exception. See here, chlorine is more. The dipole moment I have written here. For chlorine it is more, fluorine second, bromine and iodine. So since there is exception, I have highlighted here so that it is easily visible to you. So what is the exception here? Why this exception is? Carbon chlorine, the bond, if you see, the bond length is more. Since the bond length is more, dipole moment also will be more. So see here bond length value. For CF, the bond length is 139. Whereas CCl, the bond length is 178. So here what is the difference? Difference is almost 40. Whereas here if you see the difference, it will be 10 to 20. Since here the difference is very high, so the bond length here it is more. If the bond length is more, because of that you can see this exception. So learn this order. Dipole moment order will be this. Next is bond length and bond length and bond enthalpy. Bond enthalpy is nothing but bond energy. So what is the trick we are going to use is bond length is inversely proportional to bond energy. So bond length, you see, for iodine it is more, and then bromine, and then chlorine, and then fluorine. For bond enthalpy it will be reverse order. Fluorine it is more, chlorine, bromine and iodine both are inversely proportional to each other. Here there is no exception. Only for dipole moment there is exception. Chlorine is more than fluorine, but here there is no exception. You can learn this order. Next we will go for methods of preparation of haloalkanes. So here this is very important, students. From here every year at least one question is asked. So how we are going to learn this is, the first two reactions. So first two reactions I have written here in detail. We will see this. So first we will see the first reaction, that is first reaction is called as Lucas reagent. Whenever you see HCl in the presence of zinc chloride, so see the reaction HCl in the presence of zinc chloride, what is happening is OH group is substituted with Cl. So here Cl is there, therefore OH will be replaced with the Cl. So this is called as Lucas reagent. Zinc chloride in the presence of HCl, it is called as Lucas reagent. So this one same thing you will learn in alcohol chapter as well. So once you read here, so there you can just revise it. So this Lucas reagent is used to distinguish between primary, secondary and tertiary alcohol. So if it is tertiary alcohol, turbidity will appear immediately or instantaneously. Meaning is, as soon as you add this Lucas reagent, white color precipitate will appear, which is called as turbidity. Whereas for secondary alcohol, it will take 5 to 10 minutes to appear that turbidity. If it is primary alcohol, in the textbook it is given there is no turbidity, but after 30 minutes the turbidity will appear. So remember, in the question paper if it is given, turbidity will appear after 30 minutes. If it is given, it is primary alcohol. Or suppose if it is given, no turbidity appears, even then it is primary alcohol. So learn this timing. So immediately 5 to 10 minutes, and here it is 30 minutes. So this is Lucas reagent. Second is alcohol when you are treating with sodium bromide in the presence of sulfuric acid. Again OH group will be replaced with Br, because here we are taking Br. And if you are taking NaI, sodium iodide, or if you are taking potassium iodide, OH should be replaced with iodine. You will get Ri. So here we are using sulfuric acid for NaBr. If you are using iodine, we have to use phosphoric acid. So phosphoric acid is H3PO4. Remember this formula. Phosphoric acid is H3PO4. So here the question can be asked, why sulfuric acid is not used here? Instead of that we are using phosphoric acid. Why sulfuric acid is not used? Because see here the reason also I have written. Sulfuric acid is not used because it is strong oxidizing agent. What it will do is, it will convert hydrogen iodide which is formed in the reaction to iodine. So that is why we are not using sulfuric acid when iodine is taken. So for second here we are not taking sulfuric acid, and for the first one we are taking sulfuric acid. So see a second reaction, alcohol when it is treated with sodium bromide in the presence of sulfuric acid, we are getting RBr. And remember one more point here, very important. First and second reaction, it proceeds through SN1 reaction. So SN1 mechanism I have given in detail, so you can go through it if you want. So SN1 mechanism meaning is it produces carbocation. So it forms carbocation. So students, remember, wherever carbocation is formed, there you have to check for rearrangement, because stable carbocation is preferred. So that is why for the first and second reaction, whenever carbocation is formed, check for the possibility of rearrangement. So if rearrangement is possible, do rearrangement and then you attach the halogen to that carbon atom, because they proceed through SN1 mechanism. And then this reactions, see I have marked as 3. 1, 2, 3. So all this, that is phosphorus related reagents. So these are undergoing through SN2 mechanism. So if it is SN2 mechanism, then there is no carbocation formation. So here rearrangement is not possible. Only for the first two you have to check for rearrangement. So here if you are taking PX3, so here you can see phosphorus trihalide. So X3, it can be chlorine or it can be bromine. So and next is PCl5. So PCl5, if you are taking with PCl5 or PX3 or red phosphorus, what happens is OH group everywhere should be replaced by halogen. So here what halogen you are taking? So you have to replace this OH group with the halogen. So remove this OH, place Cl there. Remove this OH, and here the halogen what you have taken, you have to place it over there. But what is very important, all these are major product, but what here it is important is these two byproduct. So this is what is asked in NEET examination. So what is the byproduct formed when you are using PX3? So the byproduct formed here, it is, make a note of it, H3PO3 is phosphorus acid. Phosphoric acid is H3PO4. H3PO3 is phosphorus acid will be formed. In case of PCl5, you can see POCl3 will be formed, which is phosphorus oxychloride. So this is what you have to learn, very important, which is asked in NEET examination. And then next is fourth with thionyl chloride. SOCl2 is called as thionyl chloride. Alcohol when you are treating with thionyl chloride. So again remove OH and we are placing halogen over there, which is Cl. And the byproducts are SO2 and HCl. So this is one good method. So if they ask which is the good method to form haloalkane, so this will be one good method. Why? Because these two are gases which is formed, which can be liberated, and we are going to get haloalkane. SO2 is a gas and HCl is also a gas which will go out. So you will get this as the product. So here we will see what is given. The hydroxyl group of alcohol is replaced by halogen on reaction with concentrated halogen acid. So students, halogen acid meaning is, halogen is Cl. Halogen acid meaning is HCl, HBr, HI, all these are called as halogen acid. Then phosphorus halide, thionyl chloride. Thionyl chloride is preferred. I told you thionyl chloride is preferred because SO2 and HCl is a gas, so which will be going out easily. So the product we can get. The two gaseous products are escapable. Hence the reaction gives pure alkyl halide. The reaction of primary and secondary alcohol with HCl requires the presence of catalyst zinc chloride, while tertiary alcohol, the reaction is conducted by simply shaking the alcohol with concentrated HCl at room temperature. So here for primary and secondary alcohol you need zinc chloride. For tertiary alcohol you just shake, immediately, instantaneously you will be getting that turbidity. And one more important point here is the rate of the reaction. So first and second reaction I said it proceeds through carbocation. So carbocation stability, you know that tertiary greater than secondary greater than primary carbocation. So the rate of the reaction will be in this order. So you can see all this reaction with the important points I have written here. So here thionyl chloride is good method. So for the preparation of haloalkane, thionyl chloride is a good method because these two are gases which is easily escapable and you will be getting this product. So just go through it. All the important points I have covered. And next, the above method is not applicable for preparation of aryl halide. Aryl halide meaning is halogen if it is attached to benzene ring. So here we cannot prepare this because the carbon oxygen bond in the phenol has partial double bond character. So meaning is, so this is phenol, benzene ring, and here this is phenol. So this is having double bond character. So that is why. So you can see here carbon oxygen bond in phenol has partial double bond character. So this is oxygen and this is carbon. So this bond has partial double bond character. So breaking this bond will be very difficult. Therefore this is not applicable for the preparation of aryl halide. So this you have to make a note. So I have highlighted this, you can see, and also I have written here, you can just check it out. Because of partial double bond character, so it is not easy to break this bond. So next is preparation from hydrocarbons, from alkanes by free radical halogenation. That is, alkane you take and then in the presence of chlorine and in the presence of UV light. So what happens is it is a free radical reaction. You can see hydrogen will be replaced with chlorine. So you can get mono haloalkanes or polyhaloalkanes. Meaning is, mono meaning is only one halogen is attached. Polyhalkane meaning is more than one halogen can be attached to the alkyl group. So see here, alkane is there, and then we are taking chlorine in the presence of UV light. So here, how many products are formed? There are two products which is formed. So how do you know that two products are formed? It depends on the type of hydrogen atom which is present here. Here, how many types of hydrogen atoms are present? So see here, how many carbon atoms are there? 1, 2, 3, 4. So this is a symmetry molecule. Meaning is this you can break into exactly two half. So when you are breaking this into exactly two half, one side you count. So here 1, 2. So two types of hydrogens are there. Therefore two types of compound you will get. So what you should do is once you remove one hydrogen and place chlorine over here. So the first product you will get. So CH3, if you remove hydrogen, it becomes CH2. And then in that place you are placing Cl. Second product is remove one hydrogen from here and place Cl. So see here, it becomes CH and then one chlorine you are attaching. So two products you are getting. And then from alkene. So from alkene is addition of hydrogen halide. So what happens is carbon-carbon double bond if it is present, and if you are taking alkyl halide. So always remember that it follows Markovnikov's rule. So what is this Markovnikov's rule is, whenever two products are formed, one will be a major product and another will be a minor product. So how we are going to find the major product is, always break one bond. So double bond is present, break the double bond, place hydrogen to the carbon containing more number of hydrogen atom, and halogen you should attach to the carbon containing less number of hydrogen atom. So example I'll show you. So see here, this is carbon-carbon double bond. So check this carbon atom, where more number of hydrogen atom is present. Hydrogen atom is present here, two hydrogen atoms, and to this carbon only one hydrogen atom is present. So here hydrogen atoms are more. Therefore hydrogen should be added to the carbon containing more number of hydrogen. So break this double bond, add hydrogen here and then iodine here. So see here, major product. We have added hydrogen to this carbon, and to the center carbon we have added iodine. So that will be the major product. So this is according to Markovnikov's rule. So I have written here. So add hydrogen to the carbon-carbon double bond having more number of hydrogen atom. And next is bromine in the presence of CCl4. So this is the test for unsaturation. That is, if you take alkene, add bromine in CCl4. So bromine in CCl4, it will be reddish brown in color. So as soon as you add this into double bonded compound, what will happen is that brown color will get discharged. So it will become colorless. So what happens is double bond will break and you have to add one bromine here and one bromine to this carbon atom. So you can see here, to one carbon one bromine, and to another carbon you have to add one bromine. So that is addition of halogen. So see here, it becomes vicinal dibromide. So next we will go for the example 6.3. Identify all the possible monochlorostructural isomers expected to be formed on free radical monochlorination. So a compound is given and you have to form, what we want is monochlorostructural isomers are required. So I told you that see the number or see the type of hydrogen atom. So see the same structure. How many carbon atoms are there? 1 CH3 2 times. So 2 carbon atom here. Third, 4, 5. Totally there are 5 carbon atoms here. So same structure I have written here. CH3 2 times. So CH3 2 times it is attached to this carbon, and then CH2 CH3 CH2 CH3. So this is the formula which is given here. So here check how many types of hydrogen atoms are there. So here, how to find out is, this hydrogen is attached to this carbon. So this carbon is primary carbon, and here this carbon is secondary carbon, and this is tertiary carbon. This is primary carbon. This is primary carbon. So now primary carbon, primary carbon, primary carbon. So we have 3 primary carbon. So whether it is one and the same or different, we have to check. So see here, this primary carbon is attached to secondary carbon, Whereas here this primary carbon is attached to tertiary carbon, and this primary carbon is also attached to tertiary carbon. So these two are same. This is different because this is attached to secondary carbon. So therefore the type of hydrogen atom present here is, this is one type of hydrogen present, this is second type of hydrogen, this is third, this is fourth, this is fourth, because these two are same. So therefore four types of hydrogen atoms are present. If four types of hydrogen atoms are there, see here in the given molecule there are four different types of hydrogen atoms are present. Therefore replace it, you will be getting four product. So first what I'll do is replace here hydrogen with chlorine. So here the product, they are starting from here. So first replace one hydrogen with the chlorine, so it becomes CH2Cl. And second product is replace one hydrogen with chlorine, CHCl. Next is replace this hydrogen with chlorine, so you can see here it becomes CCl. Next is from here or here, anywhere it is the same. So replace one hydrogen with chlorine, so you can see here one hydrogen is replaced with chlorine. So totally you will be getting four product. So this is the structure which is given here. So next is halogen exchange method. So halogen exchange method, here you can see there are two reactions which is very important, name reaction. So that is Finkelstein reaction and Schwarz reaction. So students, if you need to learn the mechanism, I have done a separate video for that. So if you want to know, you can go through that mechanism as well. So here simply what you have to remember is Finkelstein reaction is used for the preparation of iodine, halogen iodine, haloiodine, alkyl iodine. That is, remember like this, Fin, Fin, I is present. Remember I means iodine. So in the preparation of alkyl iodine, we are going to use this Finkelstein reaction. So what you should do is take Rx. So here X can be chlorine or it can be bromine. You are treating with sodium iodide in the presence of acetone, you will be getting, so this will be replaced with iodine. And here one important question which can be asked is why we are using this dry iodine. So here the reason also I have given. So why we are using dry acetone is it will precipitate NaCl or NaBr which is formed. See the reaction here. In the reaction, this halogen is replaced by the iodine, and suppose if it is Cl here, Na will combine with Cl and here NaCl will be formed. Suppose if this is Br, Na will combine with Br and here it will be NaBr. So the NaBr or NaCl which is formed here will be precipitated by dry acetone. Precipitated meaning is it will be in the solid form which you can remove, separate out. So remove this, you will be having only this product now. So to precipitate NaCl and Br, we are using dry acetone. Second is it helps in forward reaction which is according to Le-Chatelier's principle. So Le-Chatelier's principle, I have done tricks on that. So if you don't know Le-Chatelier's principle, you can go through that video, go to the playlist and go through it. So what is Le-Chatelier's principle is whenever you decrease the concentration on one side. So here this is the reactant side and this is the product side. So product side we are removing this. So meaning is product side we are decreasing the concentration. So the reaction will proceed in the direction where the concentration will decrease. Since the concentration is decreasing on the product side, the reaction will proceed in the forward direction according to Le-Chatelier's principle. So this much you have to know. So I have already written all the points here. Go through this. Next is Schwarz reaction. So in Schwarz reaction we are going to prepare alkyl fluorine. So that is take CH3Br, treat with metallic fluoride. So here metallic fluoride. So metal what we are using is silver. You can use mercury, you can use cobalt and Sb. Sb is nothing but antimony. So you can use silver, mercury, cobalt, antimony. So this also it can be asked in NEET examination. So which are the other metallic fluoride which is used in Schwarz reaction? So remember these four metals. So these are the metal fluorides we are using in the preparation of this fluorine compound. So students, next video I'll start from here, that is preparation of haloarenes. So students, go through this, all the important concepts I have covered here itself. So just go through this. I think it will take only few minutes to go through this. Several times you can revise for your examination. Students, if you find this video useful, you can subscribe the channel and also share this video with maximum number of students. It will be helpful to others as well. So all the very best students, prepare well for your examination. I'll meet you in the next video.